In this video, we are going to solve problems on work, energy and power. So in this first problem, an object is kept on a horizontal surface. The force applied on the object is given by a function. So we have a function given to us where B is equal to 2 Newton per meter to the power of 4. How much work is done by the applied force in moving the object from x equal to 3 to x equal to 4? So we will use the calculus formula for work done because we have been given a function for force. So we can write work done is equal to integral f dx. So in this case, f is b to the power of b x to the power of 4 dx. And the limits are from 3 to 4. Also, we can replace b and we can write in place of b, we can write there 2 because b is given to us as 2. Now, if we calculate this directly on the calculator, we'll get the answer as 312.4. And as we are calculating work, so the unit for work done will be joules. We are going to solve another problem on work, energy and power. But here the force is being applied at an angle. So the force function is given to us, which is F equals sine alpha x. And it says that the box is moving horizontally. You want to find out the work done by the rope on the box in pulling from x equal to 0 to x equal to d. So the first thing which we have to notice is that there is an angle. So in the previous question, we wrote w is equal to integral f dx because it was not having any angle. That means the displacement and the force were in the same direction. So the force was in horizontal direction. The object was also moving in the horizontal direction. But here the force is applied at an angle of theta. So here in this case, we are going to use the vector equation f dot dx. That means f vector dot dx vector. And we know that dot product, if you want to open, if it will be f dx cosine theta. So theta is the angle between the displacement and the force, which we know here it is theta. So we don't have to do anything. We don't know what's the value of theta, but we have to write that cosine theta. So that's the first step. So you need to remember if there is an angle given between the force and the displacement. We know that the box is moving horizontally, so the displacement is in horizontal direction. Force is being applied at an angle of theta. So we have to consider that angle when we calculate work done. So now once we have got that, we have to just put the function for f, which is sine alpha x. Then we have dx cosine theta. We'll just rearrange it. So w is equal to cosine theta. We can see cosine theta is going to be a constant in this case because we are doing the integral with respect to the variable x. So cosine theta can come out. Integral sine alpha x dx. Now if you look at your formula sheet, sine alpha x can be integrated and the value for or the answer for sine alpha x will be negative cosine alpha x, and then you have to divide with the coefficient which is alpha. So this you can check in your formula sheet, it will be there. What's the integral of sine? It will be written as sine ax instead of alpha x, but a and alpha, they both are coefficients or they both are constants in front of x. So we'll divide with the constant whatever is given to us. So in this case it's alpha, so alpha will come in the denominator. And sine alpha x or sine x integral is negative cosine alpha x. So we can just rearrange it. Okay. There's one more thing, which is the limits. So we have been given the limit, so we have to introduce the limits. So I'm going to write 0 and d. Here also we'll write 0 and d. Now cosine theta is a constant, alpha is a constant, and negative can come out. So inside we have just cosine alpha x and the limits are from 0 to d. So if I put the limits, negative cosine theta over alpha stays the same. Cosine alpha d minus cosine 0. And we know that cosine 0, if you check on calculator, cosine 0, the answer will come out as 1. So I can replace that with 1. So let's just write that. So our final answer, we can write w equal negative cosine theta over alpha cosine alpha d minus 1. In this problem, we are going to see another type of situation where we can use conservation of energy. So a ball is released from rest from the top of a frictionless track. So the track is frictionless. After reaching point B, ball moves rough horizontal floor and eventually comes to rest. The kinetic friction on the floor is given to us as 0.3, and they want us to calculate the distance traveled by the ball on the floor before coming to rest. So let's say that this distance is delta x. So now we are going to look at point A, B and C. At point A, the energy which the ball had, it's only gravitational potential energy. So at point A, it had only gravitational potential energy because it starts from rest. So if it starts from rest, the kinetic energy is equal to 0. On the track, it's not going to lose any of that energy. So that gravitational potential energy will be converted into kinetic energy at point B. So at point B, it will have only kinetic energy because the height will be 0, so no GPE. With that kinetic energy, it will move forward, and at point C, it loses all of its kinetic energy to do work against friction. So this kinetic energy lost, so we can say delta Ke, what is lost, will be equal to the work done by friction. So using this concept, we should be able to find out what's the distance traveled by the floor. So the first step, let's find out what is KEB. So we said that KEB, kinetic energy at B, is equal to GPE at A. We'll just write that mgHA. So let's just leave it there. And then we know that KEC, it's going to come to rest, so that's 0. So delta KE will be equal to 0 minus mgHA. Remember, C is the final, and KEB will be the initial kinetic energy for the ball as it moves from B to C. So we can see delta KE is equal to negative mgHA. Let's bring this back into the equation here. So negative mgHA is equal to, now work done is force multiplied by displacement in the direction of the force. As here, as the ball reaches the horizontal surface, we know that the ball and the force of friction and the movement of the ball is in the horizontal direction. They are opposite to each other, but they don't make any angles which we have to consider. The angle will be 180, so we can take it as negative. Cosine 180 is negative. Or you can remember, friction is opposite to the motion of the object, so negative work will be done by friction. So we'll write it as negative force, which is a force of friction, multiplied by delta x. Now negative mgHA, negative friction is mu Fn, so we can write that as mu Fn multiplied by delta x. Now you can see that we don't have the mass given to us in the problem. That means it indicates that mass might be getting cancelled in the equations which we generate. So let's see whether we can get rid of the mass. If you look at Fn, we know that Fn for the ball, so when the ball reaches here, it will have mg acting on it, as well as it will have Fn acting on it, and these two forces will be equal and opposite to each other. It will also have friction. I'm not showing the friction here right now because we want to just know what's Fn. Fn in this case for the ball will be equal to mg. So we can write mgHA equal minus mu mg delta x. Let's see what all can be cancelled out. We can see negative from both the sides can be cancelled out, m can be cancelled out, g can be cancelled out. So we have got finally HA is equal to mu delta x. I can find delta x easily from here. Delta x is equal to HA over mu. I have the value of HA. I think that's missing from the question here. I think by mistake it got rubbed out. It is 6 meter. So HA is 6, whatever is given to us. In this case, I'm going to take it as 6. 6 divided by mu is given to me as 0.3, which is here. So 6 divided by 0.3 gives me 20. And the unit, because it's distance, I'm calculating, so 20 meters. The power output of a certain car's engine is 50 kilowatt as it moves at a constant speed of 20 meter per second on a level road. So we have got a car whose power output is given as 50 kilowatt. Okay, so power for the engine, that's the power for the engine of the car, and the velocity with which it is moving, or the speed with which it's moving, is 20 meter per second. The resistive force acting on the car is given by F equal BV square. That's the formula for resistive force, and which is given to us, the equation. Calculate the increase in the power needed for the car to maintain a constant speed of 40 meter per second on the same road. So now we want to change the speed. So the new speed for the car, we want it to be 40 meter per second. So obviously the power of the engine will change because you will be requiring more power, and you want to find out the increase in power. That means you have to find what's the new power, and then you have to subtract it from the old value or the first value which they have given to us to get to the answer. So the first thing we need to recall that power is equal to force multiplied by velocity. Now because it's moving at constant speed, so we know that the engine force, the force applied by the engine, should be exactly equal to the resistive force. Then only the net force will become 0 and the car will start moving at constant speed. So we are trying to find out power of the engine, and we are interested in the force of the engine. Force of the engine is not directly given to us, but they told us what's the resistive force. And as I said before, because it's moving at constant speed, the car's engine force, the force applied by the car engine, should be equal to the resistive force so that the car can move at constant speed. So we can write this as BV squared multiplied by V. So BV square is from the equation for force, and V was already there in the formula for power. So the power for engine will be equal to BV cube. Now we are going to use these values into the equation to get the value for B. So 50 kilowatt is 50,000 watts. B multiplied by 20 cube. So let's do that. 50,000 divided by 20 to the power of 3, and that will give us the value for B as 6.25. That's the value for B. So we can find the new power. So let's just do that, because now we have the value for B, and we also have the formula to calculate power. So let's do that. So now we can find the new power for the engine. So just to remember that this is the new power which we are calculating. The formula is BV cube. B is 6.25, it's a constant, and V is the new velocity or the increased velocity which we have here, 40. So 40 cube, and we can find the value for the new power. So 6.25 multiplied by 40 to the power of 3, that gives us 40, how many zeros are there? 5 zeros. So 4 followed by 5 zeros, and watts. That's the unit for the power. Now we want to find what's the increase in power. So increase in power will be equal to the new power minus 50 kilowatt. That's what was given to us as the original power. So 50,000, and we should be able to calculate the value for the increase. So let's do that. That comes out as 350,000. So we can write that as 350 kilowatts. That's the increase in power.